everywhere anyway.
Yeah,
Alam mo, may funny
fatal
twist yung
topic.
dulo ng session na to, guys. Like, legit. May funny twist yung buong, antay ka? Yung buong single to doubly linked list na whatever. You'd be like, so owo face, mga pa-owo kayo. Kasi parang, wow, grabe, ang galing ng transition na yun. Anyway, I probably shouldn't be spoiling it too much. Okay, sorry. Anyway, let's go to the actual business. Tapos, oops. Okay. So you get like this infinite descent here, I think. Okay. Kita ba yung code editor natin? I probably should like go back to Discord, no, and see if people are actually saying something. Is Node like yes or Node? Yes or Node?
Guys, unmute lang kayo if if you guys have questions. So it's easier for
Yeah,
Basti to hear
oh,
them rin.
legit.
It's nothing formal naman.
Wait, pero kita ba yung text so far? Or do I have to like zoom in, zoom out pa?
Kita.
Ikaw naman.
Kita.
Sige naman.
Good na? Okay, sige. Okay. So today, I think we're going to be talking about singly linked lists and doubly linked lists, specifically in the context of best practices in C, no? Kasi kung titignan mo yung mga resources out there, I've never been happy about the state of C resources. Number one enemy ko talaga yung Geeks for Geeks na yan. Parang at the surface, ang ganda tingnan na top search page rankings and everything. Pero when you look at their actual code, parang it's correct, but like, come on, man. Come on, man. Like, make it professional grade naman or something. Anyway, so I think the first thing that I want to reveal here, is to show you how many methods we're actually going to be going through in the entire session. So let me just quickly zoom out again. And makita natin na we start here sa struct node and meron tayong node init, and then all the way here to linked lists na meron na tayong list free, list print, and then push, whatever. And then we have like some main code here. So yung magiging technique natin dito is we're going to build everything from the ground up. And then yung dulo natin will actually be yung int main. Which is kind of funny, no? Kasi parang normally si main yung una mong tinitignan na program. Pero in a data structures and algorithms course, usually you start from the ground up na meron kang data structure that you want to implement, and then you only use it afterwards. Or however you wanna attack the problem. Okay, hold up. Check ko lang yun, no? Like, mga int main na walang return. Actually, wait. I'm gonna show you a quick something regarding int main na walang return. Sorry, na walang arguments. Pero may ano yun. Okay, so classic definition of a node. I'm not going to begin yung discussion natin by discussing what a linked list is. I'm going to first discuss what a node is and what are the operations that we can do on top of a node. So kunwari, ito yung parang classic definition that probably everyone's already familiar with. Meron tayong payload, which is your int data. So note na this can be any data type that you want. In reality, there's actually T, no? Where T is any data type. So kunwari kung gusto mo maglagay ng text, mag-char star ka dyan. Kung gusto mo maglagay ng long, di ba? Pwede rin yan. Ay, joke lang, wala palang long. Anyway, any data type that you want. Pero for now, I'm just going to put an integer kasi yun yung mas madali lang na intindihin. And then the next part of the struct node is yung struct node pointer. Yung pointer to the next struct node. Ngayon, yung tinanong ko kay Jod the other day is, bakit sa tingin nyo hindi pwedeng natin gamitin yung walang pointer lang? Like, bakit hindi natin pwedeng idiretso dito lang? I mean, medyo na-spoil kasi may error dun sa compiler, pero I'd like to just probe everyone here if they think, what do they think is the reason why we're seeing this error? Why is the pointer necessary here? By the way, I'm asking you guys directly, so like, you just tell me what you think while I drink my water. Okay, I need some ideas. Baka magtatawag ako ng tao dito. Judd!
So that, I'm just guessing, so that it's easier to manipulate?
Yo.
So it's easier to change its value?
I guess so, Pero more concretely kasi, if you were the compiler, di ba? Ang mangyayari dito, kung meron kang pointer dito, the size of your entire struct node is basically yung size ng integer mo plus the size of a pointer. Okay, so the size of a pointer is 8. Yes, exactly. On a 64-bit system. Pero kung Windows 7 ka na 32-bit, the size of a pointer is 4 bytes. Pero, we're living in, the future is now. So, we're living in a 64-bit world. Kaya 8 bytes yan. Tapos ito, 4 bytes yung int data natin. Pero, yung total niya should be 16 bytes kasi meron siyang padding and alignment, CS21 stuff. So, skip ko na muna kung bakit may padding na necessary. So anyway, the point is, kapag meron tayong pointer, we know exactly how big a struct node is. So kapag i-allocate natin siya sa stack or mag-malloc tayo, we know exactly na 16 bytes yung kailangan natin for a valid struct node. Pero kapag tinanggal natin to, ang sinasabi natin dito, maglagay ka ng int data sa simula, and then sa dulo niya, maglagay ka ng struct node like inline. Hindi siya pointer, you put the struct node itself. So ano ba yung struct node? A struct node is an int data na may struct node, na may int data, na may struct node, na may int data, right? It keeps going forever and forever to the point na practically infinite yung size kapag hindi mo siya ginawa through a pointer. So I just wanted to quickly show that kung bakit ganito yung declaration ng node. Kasi otherwise, infinite size yung data type natin, which is impossible. The compiler cannot give you infinite bytes. Or even any computer for that matter, no? That would be great, ano, kung infinite yung memory natin. Maybe the world will be happier, we will solve cancer or something. Pero unfortunately, that's not the world we live in.
I have a question.
Ay, lahat na. Yeah, go lang. What's up?
Instead of struct node next, since we can't do that, why don't we just use int next and avoiding
Int
using the
next.
pointer altogether?
Pwede naman. So you mean like this? Kunwari,
Or
lagyan natin siyang
kahit int lang.
size T or something? Ganyan?
Kahit int lang. Kasi all you need is the data type.
Mhm.
I'm
Well,
just
in this
interested
case
what's the
kasi,
difference.
kaya hindi natin siya ginagawang integer. Although a pointer is indeed an integer, no? Like 0x7ff something something something. Like you have a point, it is an integer. Yung fact na ginawa natin siyang pointer tells C tells C specifically na we're treating this integer with the special semantics na will pretend it's a memory location. So we can definitely turn this into an integer, pero as the programmer reading the code, it makes more sense to treat it as a memory location than just some arbitrary plain as integer, di ba? Parang it's more it communicates more information to us na naging pointer siya.
I see.
It's mostly for our sake, pero tama ka na, in reality, this is just an integer at the end of the day.
I see.
Okay, so that's pretty much yung declaration ng struct node and yung implications ng fact na may pointer tayo dito, in case you guys were curious about that. Let's start with yung first nating method of the day, which is node init, which is given this self pointer, and then this yung self naming convention na to will be used everywhere from this point forward. So given some self and given some piece of data, initialize mo yung node na yun. Ngayon, let me just clarify what I mean by self here. This is self in the object-oriented sense in Python. Kasi if you remember kung nag-object-oriented kayo sa Python, you have this self variable every time you have a class method. This is the same thing as in C. Kasi walang classes sa C. So we're going to create our own object-oriented programming in C. Para we'll just pretend na whenever we invoke this, it's as if we said node.init or something like that. Kung gusto mo maging sobrang Python nga, pwede mo pang sabihin underscore, what do you call this? Dunder init, ano? Kung trip mo talaga. Pero yung point ko lang is, yung naming convention natin, we're going to treat the node as if it's a self versus some other data. So in this case, yung other data na to is si const int data. And quick note, no? Yung, this is like one of the things na parating na we miss out on many tutorials and resources out there. Const. I have never stopped talking about const dun sa ACAD inquiries. Why should you const your data as much as possible? Kasi there are times na napapabobo ka na lang and you're going to accidentally reassign yung data mo into something else. Ideally, you would want to make sure na all of your variables are const by default so that if you do something stupid like this, yung compiler mo is going to warn you na you cannot assign the variable data to a const qualified type const int, right? So dito pa lang, meron ka ng feedback that you're doing something stupid. So, tip number 1, const everything by default, and then when you need to mutate them, dun mo lang siya ano tawag ito? Dun mo lang siya tatanggalin. In this case, sa pointers, medyo mas masaya dun sa pointers kasi there are two places where const can happen. Const can happen here and const can happen here. The way you read it is you go from right to left. So kunwari, self is a const pointer to some const struct node. So, ibig lang sabihin na to, yung self, kapag nandito yung const, self itself cannot be reassigned. So like, let's say self ginawa kong null, this is not allowed. Ayun, no? Magreklamo yung compiler na, bro, yung self mo, const siya, so ba't mo siya i-reassign? Pero kapag tinanggal ko yan, that will be allowed kasi hindi na const yung self. Pero kapag dito, kapag nilagay ko yung const dito sa referent nung pointer, that kind of means kung sino man yung behind the pointer, siya yung bawal nating i-modify. In this case, mag-error to. So just to show you how that works, no? Kapag tinanggal ko itong pareho, both of them can be modified. Kapag ginawa kong const ito, yung the pointer itself cannot be reassigned. Pero kapag nilagay ko siya dito, the referent cannot be reassigned or mutated. And if I do it on both the pointer and the referent cannot be reassigned. So as much as possible, syempre yung advocacy ko dito, if you don't need to mutate the data, const everything. So parang a const pointer to a const data. That's like the cleanest way to do it. Pero as soon as you need to mutate things, like kanwari dito, yung self.data, inassign natin, self.next, inassign natin. At this point, we have to drop yung const dito kasi that's the only way to do it correctly. So, is that part clear, no? Yung why baka kasi ma-confuse kayo kung ba't ang dami-dami kong const na nilalagay sa code ko everywhere. Basically, I'm just trying to const everything by default unless I need mutability.
Oh. So, yung values na you want to stay constant throughout your code, you put const in it to clarify?
Yes,
Oh,
exactly, And the cool thing is, kasi kapag ginawa mo siyang const, mag-iiba yung color ng data. So, kanwari, const int data versus, hindi pala to Python. Okay, kasi sa Python, sa Python support nung VS Code, kanwari, kapag ginawa mo siyang all caps, kanwari ganyan, screaming case, magiging yellow yung variable mo. Pero kapag ginawa mo siyang normal na snake case, kanwari, it's going to be red. So this is kind of nice kasi ibig sabihin nito, kapag isang tingin mo pa lang, kapag red yung variable, it means it can be modified. Therefore, bugs can happen there. Pero kapag naging yellow siya, it means it's constant. So it never changes. So bugs cannot happen there. So tingin ka lang kaagad dun sa mga yellow and red variables to know where the bug happens. Pero unfortunately, wala yata siya dito sa C editor ko ngayon. Anyway, nothing should be too surprising here na sa node init. Self.data equals data, self.next equals null. And then dito, I wrote a convenience function called node_create na siya na yung mag-malloc on our behalf. And then, this is another place that tutorials get completely wrong. Malloc can fail. if you didn't know, posible mag-return ng null pointer yung malloc. And now, if you do something crazy with it, magka-segfault yung program mo. So as a defense, no, para hindi ka bintangan ni OJ, ang suggestion ko, i-crash na yung program kaagad kapag naka-receive kayo ng null dito. In this case, I imported yung assert macro from assert.h. Ito, this one. Tapos, sinasabi ko na assert that self is not equal to null. Alternatively, you could say assert self. That's also fine. Pero personally, as a matter of taste, prefer ko yung self is not equal to null because it's actually explicit on what we're trying to assert here. Hindi siya yung parang assert self. Okay, what about self? Diba? At least kapag self is not equal to null, you can read it in English from left to right. What are we asserting? We're asserting that self is not equal to null. Hindi lang yung assert self. Maybe some of you prefer yung first one over the other, pero for me talaga, I think this is the way to go. Like, don't shortcut your Boolean conditions. So yan, one crazy thing din na nakikita ko na I really hate about other resources is yung paggamit ng malloc size off. So in traditional resources, normally you would see something like this. Parang size of struct node, right? Parang you give the data type, yung size niya, and you malloc that many bytes, and then you reassign it to some pointer na may ganun. So why do I not like this? Kasi in the future, kung gusto mong palitan yung data type into some integer kanwari, guess who now has to change yung size of component sa other side. Now you have to turn this into a size of int, right? So parang you have to change it in two places. So yung preference ko dito, instead of doing that nonsense, you just have to say size of the reference self, tapos kukunin nyo na yung size of whatever self is behind. Kasi you can think of this in terms of two steps na nag-declare muna siya ng struct node, wait lang, let me remove the const. Na nag-declare muna siya ng struct node pointer, and a struct node pointer, it knows na it's just 8 bytes, right? Kasi pointer siya So automatic yun. So ngayon, if you say size of the reference self, so parang kukunin mo yung pointer and pretend that we're dereferencing it. So in the end, ang makukuha mo dyan yung struct node itself, hindi yung struct node pointer. Kasi kapag struct node pointer, size of self will be 8. Pero kapag size of star self, that's going to be 16, right? So yung benefit nga of doing it this way is kapag binago ko to by 1, kung int star yan kunwari, automatic magbabago rin yung right-hand side na hindi na siya kailangang mano-manong duplication. And that should lend itself to like fewer bugs, no? Kanwari nalimutan mo yung pag-change ng size ng iba. Anyway, I'll go check the chat lang. Let's see. Struct node will have infinite size. Yun pala, sinagot pa ni Daryl. Oh, nice. I didn't notice. Nice, congrats. That's the correct answer. What are your NVIM extensions? This is a very modified NVIM. Balikan natin yun mamaya. Very Sir Wancho, respect. Okay, const until proven. Yes. Const by default, unless need mong baguhin, and variable name conventions. Hell yeah, my man. That's correct. Okay, so nothing too crazy naman dito sa node init and node create. So imagine nyo parang sa node initialization pa lang marami na tayong nasabi. This probably like, this probably seem like slow to you, no? Na parang, ano ba yun, Rusty? Bakit parang dami mo nang sinabi? Dalawa pa lang yung napapasadahan natin. Pero I just wanted to like lay down the foundations of why we're doing certain things this way. Bakit may const, bakit may assertions everywhere and whatever. Okay, let's drink water lang. Okay. So ngayon, as good C programmers, whenever you see a malloc, automatic yan, like automatic in your brain, you should start asking yourself, when I malloc this, when should we free yung memory na to? Kasi if you're not careful, baka madali kayo tulad ni Judd, na out of nowhere, nagkaroon na ng 15 gigabytes of usage yung RAM niya, tapos kumakit ng 20 gigabytes. Tama ba yun, Judd? Like, ano nga ba?
Bro, I thought my laptop was dying na.
Oo, like you were happily VS coding, then the next moment hindi na gumagalaw yung laptop mo. No, like we have to be careful with these kinds of things. Okay, let me just check. Umiingay yung ano. Ayun, okay. Yeah. Truly, Julia, truly. Trip Judd talaga. So, ayan, siguro a tip nga is, whenever you see a malloc, immediately plan out when you're going to start freeing it. So naturally, yung next nating method that we're going to look at is node free chain. Si node free chain is given a self. By the way, when I say self, ibig sabihin na to, this is a self na guaranteed to be initialized. Imposible yung self is not equal to, imposible yung case na magiging null siya. So there's like an implicit precondition here sa lahat ng mga functions ko from this point forward that self will always be initialized. Hindi to tulad ng Go, where, actually may mga nag-Go nga pala dito sa CS150, no? Hindi to tulad ng Go, na kapag may self-receiver ka, pwedeng maging null. That's not how it works. That's not the convention that I'm trying to put here. Whenever we say self, guaranteed it's not gonna be null. And that's something we have to enforce throughout the entire program. Sadly, no, it's not gonna be checked by the compiler, pero it's just gonna be our convention. So how do we free a chain of nodes? So kunwari, given some self, edi we just follow and traverse everything, no? So kunwari, we have like a next pointer here, so self.next, and we free yung current one that we're trying to traverse, and then we traverse forward, diba? Self equals next, and then keep repeating that while self is not equal to null. So ngayon, the reason why I did a do while here rather than a while, kasi alam ko na si self is never gonna be null. So parang sayang naman kapag nag-while self not equals null ako dito. That's literally one comparison instruction that's totally unnecessary. Kasi alam ko nang by convention, self is not equal to null. So dapat nag-do while muna tayo and then, dapat nag-do muna tayo and then the while afterwards. So I guess that's like one quick tip in terms of performance, no? Like make sure to assert your preconditions para at least mas maganda yung structure ng code. Okay, let me quickly check lang. What's this? Ingat sa malok, 51 gigs. Oh my god. Oh my god. Okay. So ayan. Next tingnan natin is node print chain. So given a self node, let me just quickly open this. Given a self node, i-print daw natin yung buong chain na yan. Since we assume na self is already valid since the beginning, we can just print it directly. Self.data. No need to say if self is not equal to null, whatever. No, hindi. No, we assume that self is not equal to null. Precondition na yun by convention. And then another thing na nakikita ko dun sa mga resources natin, functions like printf, puts, f puts and whatever, they actually return to you some error code. So in this case, yung error code niya is some integer, tapos kinuha ko siyang first, kanwari yung name niya. And then if you want to know what it means, punta lang tayo sa devdocs kanwari, tapos search natin printf. Si printf, siya si number 1, right? Return value of number 1 is the number of characters transmitted to the output stream, or it's a negative value if the output is an error. So I would like to recommend that you guys capture yung mga variables nyo dito and then i-assert nyo if it is greater than or equal to 0. Kasi at least ngayon, kapag nag-crash yung program mo sa OJ, tapos hindi niya sinabi na nag-crash ka sa line 36, so ano ito, line 36, at least sigurado ka na fault ni OJ yun, na for some reason faulty yung implementation niya ng printf na hindi niya na-print out yung characters mo. So, para at least may defense ka kay Sir Kevin kanwari na sir, hindi, it's OJ that's the problem, not my code. So here's my evidence, sir. Sa line 36, nag-assert ako tapos nag-fail siya doon. Right? So that's my recommendation on that. Anyway, next one is yung print chain, ano? So we print the first element and then meron tayong while true dito that traverses the list. Tapos if self is now equal to null, we break out of the loop and then we just print out the element otherwise. So kanari, meron tayong 0, 1, 2 with some arrow and whatever. No? And then sa dulo, I'm going to put a new line para mas malinis tignan yung output. So literally put char and then I assert that it's greater than or equal to 0. Nothing too crazy, hopefully, no? Yeah. Siguro yung parang pinaka-crazy lang dito is yung fact na ina-assert ko yung mga error codes coming from printf and put char. That's something na you don't see at all anywhere. Like, I assure you, kung pumunta ka sa Stack Overflow or pumunta ka sa Geeks for Geeks, no one does this. It's a little bit frustrating actually kasi mali yung ginagawa. Anyway, now we get to the exciting part kasi ito mga infrastructure lang yung parang pinapakita ko pa lang, ano, yung initialization, how to free a node, how to print a chain, and so on and so forth. Now, we can start looking at yung more interesting functions like itong si swap chain. Si swap chain, you can imagine, I should probably draw that, no? Okay, let me just open my thing. That's what I said. Yun, pwede pala. Okay, there. So, let me quickly close this para hindi tayo maubusan ng RAM tulad ni Judd.
Out of fuck.
Okay. So, one of the core primitives that I want to first introduce is the notion of swap chain. So, let's say meron tayong isang node, right? Ito si self. And we have another node here. And itong si other node is possibly, joke lang, ito muna. Si self, possibly meron siyang ibang nodes right after it, right? Or meron din siyang node dito. The point is, we don't really care. We only care about itong si self lang, right? From the perspective of everything, ito yung mundo natin. Si self lang. We don't care about everyone else. So ngayon, let's say, si self, gusto natin siyang lagyan ng, patungan natin to ng other. So, kanwari, other. Tapos si other itself, posible din may prefix yan, or whatever, posible din siyang may suffix, or so on and so forth. And yung goal natin, we want to make sure na itong wala pala siyang prefix. Kasi yung function signature niya is given a node na myself, and then another node as well. So, imposible pala yung may prefix. Ito lang pala siya. Same din pala kay self. Sorry, never mind. Ito lang. Ito lang pala. So, given na meron kang self and meron kang other, I want to make sure, yung swap chain is, i-break ko yung chain na yan, tapos i-connect ko siya dito, and then kung sino man yung dangling chain na to, siya yung i-return ko sa caller. So, kumbaga nag-replace tayo ng chain, right? We plucked out this entire list of nodes here, parang tapos ni-redirect natin siya to other, and then this is what we return back to the caller, whatever this dangling chain is. You can imagine this atomic operation here na sinaswap natin ni-redirect natin si self, tapos binibigay natin yung remaining elements. This will be especially useful kapag meron na tayong mga splicing operations, meron na tayong append, pero mamaya na natin pupuntahan yun. No? Actually, I think one of your labs was splicing operation yata, no? So parang dito pa lang na siguro na bahala na kayo na parang, oh my God, yun lang pala yung kailangan kong gawin. So, anyway, to implement that, medyo madali lang naman. Si swap chain, you keep track of the old pointer, yung si self.next, right? And then si self.next, you point it to the other, and then you return the old one. That's it. Like literal na, that was the entire operation that we just did there, right? Makes sense, ano? Na ito si old, right? Or si old. And then, ni-redirect lang natin, and then we return si old back to the caller. Ngayon, si caller na bahala what they want to do with this dangling chain, no? Pero we don't really care about that kasi as far as the swap chain is concerned, we finished yung operation. Okay? Cool so far? Cool? Let me just check in chat. Okay? Great. So now, ito na yung exciting part, si append. How do we append a node after another node? Medyo madali lang yan, actually. You'd be surprised na yung append operation natin, we can actually express that in terms of yung swap chain. So given a node self, this one, tapos given another node, yung goal natin is to append the node right after the other. And then naturally, that's just a swap chain. Meron kang self, tapos meron kang other, right? So like in a perfect world sana, this would have been self.swap chain other, right? So kung kanwari sa Python yan, pero wala namang object-oriented sa C, so we have to do it this way. At sa mangyayari niyan, we're going to get the old chain back. Yung old chain na yan, if we were appending a single node, dapat maging null yan, right? Magiging null pointer lang. Pero kung hindi siya naging null, yung ginawa ko na lang dito is I'll just free the entire chain. Like, I just let go of it and then we're done. So, you don't have to do it this way. Kasi kung kanwari meron kang problem sa OJ, which requires you to take a look at the dangling chain and do something with it, edi syempre you can return it. Yung point ko lang naman dito is we can express the append operation in terms of yung swap chain and then do whatever you want from there. In my case, I just freed the chain because I don't really have a use for it. Okay, is that clear? Is that clear? Just wondering, baka nawala na kayo eh. Oops. Ooh, gumalaw yung mouse ko. Okay.
Basti, is it
All good? All good?
is it okay if you
Sorry.
if you also can you help me or us visualize it how that happened
Which one?
per code?
Yung swap chain? This one?
Yung append.
Okay. Yung append. Okay, so we've seen yung swap chain, no? So parang familiar, okay na tayo dun sa swap chain. No?
Yeah, I'm all
So if you wanted to append something, meron kang...
given two nodes.
It's actually the exact same thing as... It's the exact same thing, ano? Meron kang self, meron kang other. So kunwari ganyan, dot. Meron kang other. Tapos originally, they point this way. So yung first step, sabi daw, perform node swap chain. So okay, si node swap chain, if you look at the definition, we keep track of the old pointer, this entire thing here, right? And then we're going to break the chain. Swink! Like that. We're going to break the chain. And then we're going to reassign yung self.next to be pointing to other instead. So that's going to now be here. That way. And then after that, i-return down natin yung old. So this is the one that gets returned to the caller. So ngayon, if this happens to be null, so kunwari null lang yan, don't do anything, right? Pero kung sakaling may laman yan, na may nodes yan sa loob, we're going to have to run node free chain on it, like this. So kumbaga, ano lang yan, node-free chain, and then one by one, ipapurge natin yung mga nodes na yan from left to right. And ngayon, hindi nasasabog yung memory natin kasi na-free natin yung unnecessary nodes.
Oh.
Pero in the typical case, kapag si node only contains a single node, so kanari, sige, let me visualize that more concretely, no? If you wanted to append a single node, it would look like something like this, ano? Meron kang single node. Sorry. Normally pala si self, wala siyang null to, right? Normally it's null. So ngayon, when you redirect it to here, tapos you give the dangling chain, it's going to get null. So technically, walang mangyayari dito sa if old is not equal to null, no? So, in the typical operation na yung node mo is only a single node, dapat walang mangyayari dito. Although, note ko lang though, na si self, yung sabi ko kanina na convention natin, si self ina-assert natin as a precondition na bawal maging null si self. Pero if I noted here sa taas na si other dito, we actually accept the case na possibly null si other. Kasi it kind of makes sense na pwede mong assign to null yung self.next. Okay lang yun. Pero yung self, yung bawal natin gawing null. So if you think about it, kapag sinet natin to null explicitly, parang ang ginagawa lang natin, kina-crop lang natin yung chain. So kumbaga, starting at self, just crop everything after self. So like, if you wanted to do something like that, magiging node swap chain, self, tapos sabihin mo lang null, di ba? Parang starting at self, crop everything to the right of it. That's one way to implement that operation. Pero in this case, ginawa ko lang siyang take whatever's in the old chain and then just free everything. Okay? Is that good, Judd?
Yeah. Thank you.
Okay. So next natin would be yung get nth in chain. So literally, lang yan, given some node, tapos some integer n, make sure you give me the nth element. So if you notice, yung for loop ko, nagsimula siya sa 1, kasi yung 0th element corresponds to si self. And we know that self is already initialized. So like, there's no point in starting the iteration at I equals 0, right? So, kasi sayang lang yung CPU cycles mo. So if you try to search for get nth in chain of 0, the for loop will get skipped and we just return self immediately. Otherwise, kapag get nth 1, edi we're going to traverse forward one time and then we're going to check muna kung if there's like a node after us, right? Kung merong node after us, ibig sabihin na exhaust natin yung buong list without reaching yung n, in which case we say return null. Hindi natin nahanap yung nth element. So yeah, I hope this is not too crazy naman, literal na linear search lang yan. Tapos if ever you find it, edi return. And then dito, another interesting thing here is get last in chain. See, get last in chain is like parang get nth in chain, pero guaranteed na dapat papunta ka sa dulo ng list. This will be extremely useful later kapag in-implement na natin yung list append or list concat. So kanari dito, we traverse all the way to the end of the list. The node chain. I'll make sure to say chain instead of list kasi yung list is like for later pa yun. We're just talking about nodes for now. So yan, to get the last in chain, just iterate all over the chain, hanggang mapadpad ka sa dulo and then return self itself, or whatever. Okay? And then, itong function na to, si node detect cycle, mamaya natin babalikan yan kasi ito yung parang very clever algorithm for cycle detection. Okay, so I think we reached the end of the node operations. Linked list na yung pupuntahan natin. But before we go there, I just wanted to ask if everyone's still following.
Grabe, nagigets nyo? Ako lang nagtatanong. Ako ba yung pinakabobo dito? Ang ina naman.
When to use size T and loop? Good question. Okay. Size T and loop. Whenever I do iterations, I just prefer using size T as much as possible. In this case, it's not necessary. You can actually use int here if you want. Although I hate using signed integers for iteration. at the very least, gumamit kayo ng unsigned int for that. Pero out of habit lang na gumamit ako ng size T kasi it's a pretty big number. It's an unsigned long. So, right? Like, there's possibly no way that you're going to exhaust all the unsigned longs, right? So, ganun. Anything else, my dudes? Anything else? Clear naman si swap chain, si append. And, syempre, you can implement yung prepend operation in terms of append. So parang flip mo lang yung arguments niya. We'll look into that later pa. Pero as long as we have these core primitives, no? Ito yung parang maganda na yung foundation natin for building the actual linked list. So far, chains pa lang yung ginagawa natin eh. Okay? All goods, all goods? Let me know if I should proceed or if I should not proceed. Not proceed. Oh shoot, so nga pala may nangyayari sa ACAD inquiries, hindi ko na nakikita. Hala, they're probably still talking about prob set, ano? Question for 138. What did y'all do? Oh my god, good times! Nakakamiss to yung may QR, whatever, ganun. My god. Okay. Sige. So, we head back to work, I guess, no? Or am I right to assume that we can move forward na? Sige, wait. Let me zoom out the code just in case may mga tanong kayo specifically about it pero hindi nyo ma-express because you're not looking at it right now. Okay. I think I'll have to zoom out a bit, but whatever. Okay. Sige, going once. Do we have like any other questions? Going twice. Okay, we're going to linked lists. Let's go. So, ito na yung, na-build na natin yung foundations with struct nodes. Now let's talk about yung linked list. Si linked list is naturally just the pointer to the head. And yung pointer to the head is just the struct node pointer itself. Yun lang, yung definition natin for a linked list is just a pointer to the head. Kung null yung head mo, empty yung linked list. Pero if you have a single node there, edi hindi ka empty, di ba? So how do we initialize a linked list? Ito lang yun. Given some pointer to a linked list, self.head equals null. Tapos dito rin sa list create. In this case, I did stack allocation. Hindi ko siya ginawang malloc kasi it's kind of weird to malloc a pointer kasi you can just easily copy that onto the registers and whatever. The point is, we can just put that on the stack. There's no need to dynamically allocate it. So, ayan, inallocate ko sa stack, list init onto the stack variable, and then we return whatever that struct is by copying it into the caller. And note na yung copy na yun should be extremely cheap. Like, in fact, zero cost even. Kasi yung struct list is just a single member na literally pointer lang. It's 8 bytes. Your CPU does 8 bytes copying every single cycle. So it's practically zero cost. Just to prove to you guys, no, it's just 8 bytes. There's nothing special about it. So we can copy the entire struct and put it to the caller. Okay? So syempre, as I mentioned earlier, meron tayong list create, meron tayong list init. Let's talk about how to free the entire list. And essentially, sabihin lang natin, check muna natin if the head itself is null. Note na yung sinabi kong convention kanina is si self yung imposible dapat maging null. By convention. Si self yung dapat hindi null. Pero I didn't say anything about self.head. Right? So, in this case, we can access si self.head directly without checking if self is not equal to null kasi yung convention natin is self will always be valid. Anyway, kung yung head natin is null itself, we don't have to free anything. Otherwise, we have to node free chain starting from the head. And then after that, let's make sure to reinitialize yung list so that naka-null yung head. Just so we don't reuse bad pointers, di ba? As a best practice. So, ayan, make sure to clean up after yourselves. Yun yung sinasabi ko lang dito, right? If you want to free the list, make sure to leave the list in a valid state afterwards kasi you're going to start wondering if you accidentally use the list again, biglang, oh, shoots, bakit ako nag-seg fault on some use after free kind of bug? Well, this is gonna stop you from shooting yourself in the foot, no? So, ito yung parang important step, no? Okay? Let me just quickly check yung... Okay, wala naman.
My question ako, Basti. Di ba kanina we talked about chained nodes And now we're talking about linked lists. But can you
Mhm.
help me visualize yung it's kind of fuzzy
Nice.
how they're
Sige, sige.
different eh.
Yeah, sige, thank you, Judd. That's a great question. So, when I say struct node versus, the chain of nodes versus a node versus a linked list, what I mean is, pedantically speaking, this is a node, right? Nandito yung data mo, nandito yung next pointer mo. This is your 16 bytes, right? When I say node, this is the node itself. Yan. Node lang yan. Or struct node, or whatever. Pero when I say, this is one node, this is another node. So now you can have like an arrow pointing to that. This is another node, right? That's another node. And the entire data structure itself, the entire data structure itself is, if you wrap it all up inside this bigger box, that's what I call the linked list, right? Just to distinguish between the node itself, like the node as an abstraction, versus yung linked list that uses, versus the linked list, which is an abstraction over the abstractions, parang like multiple layers of abstractions here. So, kumbaga itong si linked list has a head pointer, tapos yung head is a pointer to some node, tapos yung node itself can be a chain of other nodes, right? So when I mean to say linked list, it's just a head pointer na may possible chain of nodes.
Ooh.
Okay?
So a linked list is basically a chain of nodes na may head tsaka tail. If
yung tail is not necessary. Sa tail, sa doubly linked list na natin titignan yan.
Okay.
Ito for now, singly linked
basta may
lang.
head.
Although, no one's gonna stop you from putting a tail sa ano. So, kanari, you mean, kanari, ganito, no? Tail. Okay lang yan. No one's gonna stop you from putting a tail dun sa linked list mo. Yung problem lang dito kapag naglagay ka na ng tail, you have to make sure that the tail is correct as well. So, kanari kapag nag-list init ka, dapat si self that tail is equal to null. And then if you're going to free it, dapat pati si tail na free mo rin yung, dapat mag-make sure ka na reset mo siya to null as well. Mas marami lang siyang bookkeeping involved. Pero you can do something like that. Yung to simplify the implementation, head pointer lang yung gagawin natin for now.
Ooh. Thank you.
Although yeah, feel free to do something like that. Although it's kind of funny kapag gumawa ka ng tail pointer in a singly linked list kasi
Pinahaba
diba
yung
mangyayari nun kasi mangyayari nun diba nandito ka tapos what's interesting here null yung dulo niyan diba, so like what are you gonna do? I guess if you wanted to access the last element in O of one time, sure, that's your code. I'm not gonna stop you from doing that, pero those are your options. So yeah, nasagot naman dyan.
Thank you. Perfect.
Okay. So now, may tanong si Alice. Basta you have self as non-null. Para you still have access to the list, even if the list you have. Yes, exactly. Although yung non-null na to is just a convention from me. Hindi required na si self is always null. Pero sa akin, I'm enforcing that convention sa code ko so that I can always assume na whenever I'm building my abstractions, I don't have to worry about some dumb stuff, like some dumb shit like assert self is not equal to null, like something you would do in Go, for example. Gur sa Go, no? Gur at Go. Sino ba yung mga nag-CS 150 ngayon? I'm pretty sure you guys are frustrated by that, na kapag yung receiver mo is not equal to nil, tapos parang gagawa ka na parang, like, nasty. So I'm just not even gonna deal with that. I'm just gonna assume na self is never gonna be null. Anyway, sige, let's talk about printing the linked list. Madali lang yan actually. Same bananas earlier. Kung sakaling si head pointer natin is not equal to null, so ibig sabihin valid siya, may laman yung chain of nodes natin, and then we just invoke yung internal na node print chain on the head itself, right? So if you notice, like we're literally just reusing yung mga functions natin from earlier to build this larger data structure in terms of primitive operations. Pero kung sakaling head is equal to null, edi we're just gonna print a star. Yun lang. Star lang, just to signify na walang laman yung ano. And then syempre, as good practice, we have to make sure na yung result is greater than or equal to 0. kung sakaling mag-crash si OJ, tapos magalit si Sir K, bakit nag-crash yung program mo? Hindi kasi sir, yung problema yung servers ng DCS mismo. Kasi tingnan mo sir, sa line 137 may assertion failed, eh dapat hindi yan mag-fail or whatever. Anyway, so now we can now talk about yung how do we NQ and DQ items from a linked list. So yung first nating titignan is itong si list push front node. Like, it's a pretty verbose name, pero essentially ang trabaho niya lang is given a list, no? Meron kang self and meron kang struct node, append the node before the head and then reassign head to be that node. Right? Well, sige, let me quickly draw that a bit. Ano? So meron tayong linked list, right? Oopsie. Meron tayong linked list and then you have a node. This is your head, right? This is your head. And we have some node other, right? Ito si other node. So yung goal natin is to have yung goal natin is to move yung other into here, right? And then we're going to quickly put this like that. Ang late na ano. Late ng drawing. We're going to point it to the head and then we're going to reassign the head itself to be this guy now. Chanan! That's your... Ay, hala! Naiwan yung ano. Naiwan yung isang head. Let me quickly fix that. Shoot. Ay, hala. What the heck? Will this work? Oops. I don't know what I did. Okay, whatever. Okay. Ayun. Oh, God. Yun. There we go. Head. There. Okay. So that will be the new linked list, ano? So if you wanted to push to the front of the list, essentially, you just have to move the head backwards and then prepend the node that you want to insert. So literally 2 lines of code, no? Append node self.head, and then si self.head is now the node itself, right? Okay? Nothing crazy about, whoa, look at that infinite descent, bro. Wild. Okay, I was about to just check the chat, eh. Okay, no questions man? Dun sa ano? Sa implementation ng push front? Yo? Yo? Y'all doing good there?
I'm good.
John, nagalag ka yata.
Hello.
Okay lang, sige.
I just said I'm good. Grabe, nagkikits
Okay.
ka. Ako lang talaga nagtatanong.
No-follow nila eh. And ito, gumawa ko ng wrapper function lang dito. List push front data na if you give it the integer directly, edi ako na yung mag-initialize ng node. So this is like a helper function lang. Kasi in case I don't want to construct the node myself. It's the same thing. Yung next one natin is list dequeue. This is like one of the core operations then. So essentially, you take the front of the node, you take the front of the list, and then you pluck out the first element, right? So if you wanted to dequeue something, essentially, you just have to extract the head, right? Extract mo muna yung head, and then if the head itself is equal to null, don't do anything, right? Parang i-return mo na yung null na yun. Pero kung hindi null yung head itself, well, this is where the fancy stuff happens. Yung self.head natin, we're going to skip ahead, i-move forward natin yung head so that it's node.next now. Tapos yung whatever the original node.next is, we're going to break yung connection niya by setting this to null. And then we return yung node na yun. So just to visualize what that looks like, if you want to dequeue something from a node, we have this. Ay lang, naging pink. Let's stick to the blue para consistent yung pattern. So if you wanted to pluck the head, right, you just have to, ito kanari si head, you just have to move yung head pointer mo to node.next. So this is the new pointer, right? This is the new head. And then you're just gonna have to make sure to break the connection like that by setting it to null. And then ito, yung i-return mo sa caller. Shoop! Right? Parang i-dequeue mo siya, ipa-pluck mo siya out of the list. Right? I hope that makes sense, no? Yung yung may animation pa tong visualization natin. Okay? So that's list DQ. So now, let's talk about reversing a list. Kasi it turns out, 18% lang yung nakapagsagot nung Lab 2A on how to reverse a linked list. I'd like to give a shout out to my boy Lucas here kasi siya yung nag-float ng idea of treating a reverse as a series of DQs. Thank you, my man. Huge help. So we can think of a reverse operation as simply dequeuing from the node one by one, tapos one by one mo siyang iko-concat dun sa dulo ng list itself, right? So parang you can imagine na if you wanted to reverse the linked list, edi pluck the elements one by one, put them sa dulo, right? And then prepend, lagay mo sa dulo, then prepend, lagay mo sa dulo, right? So it's a very cute way of thinking about it. Na reversing the linked list is just a series of dequeuing. So yeah, if you want to reverse, we just have to take the head, and then head. If the head is equal to null, don't do anything. There's nothing to reverse. Pero if there is something to reverse, keep dequeuing. No, take whatever this node is. Tapos if it happens to be null ulit, edi wala na tayong gagawin. There's nothing to reverse anymore. Otherwise, we just append the ano tayo ito? Sorry, rather we parang I say append here, pero technically we're prepending it to the head kasi parang node and then after that yung head. Kaya parang prepend to the head. Pero like semantically the same, iba lang yung perspective. Tapos kapag nagawa mo na yan, yung head mo is now equal to the node. So kumbaga yung head pointer natin, as we keep dequeuing one by one, yung head mo nag-move forward siya, gumagano'n siya. It keeps propagating forward and forward, right? Hanggang sa maubos yung buong list, right? So imagine it starts here, then you go here, then it goes here, and then here, right? It just keeps jumping. So yan. Kapag na-exhaust na natin yan, we finally set yung head to be wherever the new head ends up in. So, effectively, kapag nasa dulo ka na ng linked list, right? Edi yung entire thing, right? Oops, baka naging purple siya. Ay, naging orange siya. No. So, effectively, what happened is, yung linked list mo, yung head mo nasa dulo na. And then yung mga arrows mo, pag gano'n na siya. Right? Okay? Is that clear? All good ba? All goods?
All good for me.
All good. All right.
Maybe, Basti, maybe we can have a 5 to 10 minute water CR break.
Hell yeah. Okay. No
been
probs.
Yeah, it's been an hour. To lang.
Sige lang.
Baka break.
We'll be back in like 8:05 or something.
Yeah.
That should give me enough time to back read on the what's been happening in the Akad inquiries. What is happening here? Highly discouraged to use the formula row. That is true. Yes. The inverse is computationally expensive. That is so true. It didn't cover how NMOS and PMOS behave given source and gate voltage, or am I blind? Oh my god. Good times. Good times. Back in my day. Oh, ayun! Ellis! Salamat. Ito ba yung soundboard? Oh my
Wait,
god!
ang angas.
Hindi ko lang siya ma-soundboard. 5 seconds. Siguro yung yung maganda yung tapos yun lang. Magka-cut off na siya dun. Or actually, pwede rin yung intro lang eh. Like yung... Oo, pwede rin yung intro lang eh. Kasi that's enough to get you into the PTSD of it, diba? Yung marinig mo lang yung intro, maggulat ka na. yun! Hell yeah. It's so good. That's so good. Sobrang perfect yung pagka-stop niya dun sa ano. Dun sa, I don't know if the kids call it the drop or whatever. The drop, sabihin na natin. Our IoT Cup project sa assistant series intro music. Oh my God. Wait lang, naalala ko yung yung first exam natin, di ba, Ellis? Ay, first system series exam natin. That was like 140, di ba? Tapos yung ginagawa lang natin nila ni Ram nun. They were like jamming to Green Flash sa Melchor. Oh my God. Good times. Imagine mo yung first experience natin ng UP. Nag-green flash tayo sa study hall. Oh my God. What a bunch of weirdos. I don't know these people. Oh my God. Okay, it's almost 8:05. Judd, are we doing good? I hope he's vibing right now. Okay, wait now. Let me go reshare my screen na rin while we're at it. I joke. Wait lang. Okay. Ay, mali pala. That's not what I wanted. Will you send the file? Good question. I haven't thought about it. I have not gotten that far yet, but I probably should. Siguro I'll just open source it, just so it's like more available. I don't have to like email it to everyone. Basta start niyo yung repo Like I'm looking for the new GitHub cloud, okay? Gusto ko yung I'm starting my new influencer phase. dapat i-start niyo yung repo na yan, Okay.
You could also
Send the
just
link
send
sa
it as a code block. Pero I guess the repo thing is also...
Hindi, pero malaki kasi. Malaki kasi yung file. It's like 5 kilobytes or something. Well, I'm aware na may limits yung OJ na 1 kilobyte. Pero it's not like you guys are going to use all of the functions na nilagay ko dun sa Wait. I'll be careful sa pag-open source niya. Kasi I'm fully aware na madali siyang i-copy and paste kung sakaling
Yes.
Hindi naman. Kasi tapos na yung linked list era ninyo dun sa labs. The next time you guys will be talking about linked lists will probably be sa Hope na. And you don't even have access to GitHub sa Hope exam ninyo. Sige. I guess I could. I-open source ko na rin siya. Sige, I'll just send it to, I don't know, like, general or something kapag na-ready ko na yung repo. Okay, sige. I think we can resume. Let's go to share the whole screen again. Tchanan! Okay, are we good? Kita ba? Quick question lang.
Kita. Good
Hell
try.
yeah. Okay. So the next operation that we're looking at after reverse is take. So si take, given a linked list, take the head. That's it. It's such a basic operation na I don't even have to demonstrate yung visualization kasi look, yung take operation is look at the head, right? Tapos kunin mo yung original linked list, set mo to null yung head niya, and return the head. So effectively, pinlock out natin yung buong chain out of this list, tapos ni-return natin. So like, you're probably wondering, why is this useful, Basti? Why are we gonna pluck out the entire head chain? Diba? Like, what's the use of that? Well, may kinalaman yan siya dito sa list concat natin. Kasi sa list concat, it takes in 2 arguments, a self and an other, tapos yung self and other na yan are 2 struct lists pa rin. So, As usual, no, const pa rin yan, and so on and so forth. Pero, if you wanted to concat two lists one after the other, kung sakaling yung head ng self is already equal to null, so like empty list na siya, edi for you to concat the list from the other one, you just have to like take from the other, di ba? So self.head, take from the other, and then return. That's it. It's such a cute thing, ano, na you can just like pluck out yung mga little operations na yun and call it like some word in English. That's a take operation, that's a swap or whatever. So, ayan, if the head is null, we'll just steal the other head by taking it, di ba? Otherwise, kung yung head natin is actually populated, we're gonna have to do something more, fancier than that. Specifically, we're going to have to traverse the entire linked list muna. So, dito napapasok yung get last in chain na method natin from earlier, which should give us a pointer to the last node in the chain starting from head, right? And then, after that, one by one, i-DQ natin from other. So like, take note, this is other, this is not self. We're going to DQ elements one by one. Tapos kung sakaling wala na tayong pwedeng ma-DQ, we just break out of the loop kasi parang ibig sabihin na exhaust na natin yung other list. Pero kung sakaling meron pa tayong pwedeng i-concat, we just append yung last, wherever the last is, and we'll append yung node na yun na DQ natin from other. And then let's make sure to advance forward yung last pointer natin just to make sure na it truly is the last one in the list. And we just keep repeating that over and over again, right? Hanggang sa ma-DQ yung buong list. Okay? All goods? Yeah, sorry, I wasn't able to follow. What's the difference between the structure of list? Yeah, okay, sige. So, Kiro, ito pala, sorry. So when I say node, no, let me just quickly repeat, no, yung tanong ni Judd din kanina. When I say node, I refer to this lang, yung data and then the next pointer. Like, that's a node. And then a node can possibly have a chain of nodes after it. So that's a node, that's a node. So like literally the single box. So when I say a linked list, that's basically the entire chain itself, right? Nakabox siya. So if you look at the definition of struct list, literally, it's just a pointer to the head. Yun yung definition ko of linked list. Okay? Gets? Okay? Ala, paalis na si Jelly. Joke lang, umalis na si Jelly. Alright. Moving forward, we have, ayan si list concat. Now we have list split nth. I think nilagay ko to kasi at some point meron kayong lab where you had to splice a list somehow. So itong si split nth, given some index n, split the list there and then parang mutate mo yung self and then give me the resulting new list out of that, right? So, okay, hold up. Let me quickly check yung sana matapos kang command by the time na matapos yung session. Okay. Anyway, so essentially, ang una natin gagawin dito is to get the nth node in the chain starting from head. So, I'll just assume kunwari na, sige, let's not assume anything pala muna. Let's try to get this. So, this is possibly null. Possibly null. Pero mamaya na natin iisipin yung null. And then, we're going to initialize a new list na yung head niya is equal to null. So, like, wala siyang laman. Ang gagawin natin next, I should have probably used node. I should have probably used list crate. Yeah, that's much cleaner. Okay, that looks good. I am satisfied by that. That looks really good. Okay, so kung sakali yung node na na-pluck out natin sa get nth in chain is not equal to null, or sorry, let's start muna with equal to null. If it's null, we skip, right? Don't do anything. Just return the empty list that we created earlier. So, ang equivalent ng sinasabi nun is, hindi natin nahanap yung nth list. So, walang nagbago sa self, and we just return to you an empty list, right? So, basically, wala tayong na-splice. Pero kung yung node natin is may nahanap tayo, then we're going to look at the head of this list, right? The one that we just constructed, and we're going to point the head of that list to itong si node.next. So parang kunin mo si n, and then kung sino man yung next one after n, siya yung head nung dude na to. And then after that, si node.next, like whichever we found, we're going to break yung connection niya, break connection by setting it to null like this. So effectively, we now have two lists, right? Meron tayong self and meron tayong other, like the one that we returned. So do we have to do a visualization for that or clear naman yun? Ayun pala, nag-emotes pala kayo dito. Ngayon ko napansin. I probably should have been saying that pala, no? Like rocket reacts or something like that. Crab reacts. Thank you, Alice. Okay. Sige. Yeah, pretty cool, ano? List split end. So that's it. Nasa dulo na tayo. Like, literally, na-implement na natin lahat nung mga basic operations that I wanted to discuss. Minus yung detect cycle. Yung detect cycle, kapag may time tayo, we'll discuss that. So now, just to give you a taste of what it looks like, no? Sa main code, ito lang siya. C code can be beautiful too. Ito lang yung point na gusto kong i-drive home. So kanari meron tayong list A, list create, push front, list print, tapos detect cycle, whatever. Tapos list create, push front, di ba? Like, the point that I wanted to show here, no? Like, C code doesn't have to be ugly, right? Normally, when we look at resources like dun sa Geeks for Geeks, ang pangit tignan ng code nila, diba? Parang daming mga flying variables everywhere that are not even initialized, nasty looking. Pero like, if you abstract your data structures properly, you have something that looks like this, and it looks really clean, diba? So, oops, detect cycle. Yeah, para ma-check kung acyclic. There's like a really nice algorithm for that. I don't know if you've heard of yung tortoise and hare algorithm ni Floyd, pero we'll look at that later pag may time. Kasi yan, if you wanted to concat A and B. So, sadly, wala kasing object orientation dito sa C. So, normally, you would do something like this, A.concat B. Pero we're doing our poor man's object-oriented programming. Kasi yan, list reverse, print list, so on and so forth. And then, since we're responsible people, we free the list when we're done using it. Tapos, just to demonstrate yung cycle detection, I just printed out yung nodes. Tapos ito, may malaking to-do tayo dito. Hindi ko pa na-implement yung how do you print a list na may cycle. Kasi if you're not careful, like dun sa current implementation ko ng list print, this will cycle forever, right? Si node print chain doesn't actually account for the fact na possibly forever siyang iikot. So I'll just leave that as an exercise for you guys na how do you account for a cycle. So syempre medyo kailangan mong gamitin yung node detect cycle for that, pero for the sake of brevity, hindi ko na siya ginawa muna. So yan, let's just quickly check what that looks like, no? So let's compile. Ito yung compilation commands na ginamit ko. We have w-all, extra pedantic error conversion, no pointer arithmetic, and level 3 optimizations. If you're wondering why it's this strict, kasi I always learn something new whenever I see warnings from the compiler. So for example, if you've always wondered kung bakit yung code ko sa main always features void dito sa simula, parang you're probably wondering, ba yun ang difference nito kapag wala akong nilagay na void dyan or kapag wala siyang arguments. Kasi it turns out, di ba, kapag nag-compile lang tayo, it turns out, sorry, double link pala yan. It turns out, if you run this, yung warning, yung dating warning, kasi right now, yung ginawa ko, nag-w-error ako. Ibig lang sabihin nun, kapag may warning yung code mo, treat it as if it were an error, so it doesn't even compile. So in this case, let's quickly read lang what this error says. A function without a prototype is deprecated in all versions of C. So it turns out pala, we learned something new today, na if you have an empty argument list in C, that's actually deprecated behavior. It's wrong. So the correct way to do it is for you to actually say void dito. And now you can actually compile it. Diba? So that's the reason why I turn on my warnings to all these strict levels. Because eventually, something's gonna trip me up and I'm going to learn something new. Diba? So, ayan, I just wanted to share that with you guys kasi parang I highly encourage turning on all these warnings sa code ninyo. So, you don't get like gobsmacked out of nowhere kapag hindi pala gumagawa ng expected behavior yung code or something.
Pwede pa
So,
send
yeah.
sa chat, Basti, yung error warnings.
Sorry, ano yun?
Pwede pa send sa chat yung error warnings.
Oh yeah, sige. Here you go. This is like standard for all of my C projects. Like, let me just
So
put this
whenever
in Bash.
we run a code, no, that makes the warnings into errors, so that it catches the errors before you have to deal with them. Parang ganun.
Or more like, it captures foot guns. I mean, sorry, it parang pina-flag ka na kapag may ginagawa kang kababalaghan sa C code mo.
Kapabalag.
Like, kanwari ito. Let me show you. This is a very common thing that a lot of people do. Okay, so int, right? Sorry. Tama. Int yo equals 8. Unsigned int hi equals yo. Like, no, there's no warnings or anything. But it is pretty bad kasi posibleng mag-overflow yung yo natin. So if you try to compile this under my settings, itong si w-error and itong si w-sign conversion, mag-flag yan. Sasabihin niya, bro, what are you doing? Ba't ka nag-assign ng int sa isang unsigned int? Stop it. Di ba? Stop introducing bugs into your code, bro. Pero if you so insist, okay, wait lang. Let me quickly note here, kanari unsigned to. If you insist on assigning an unsigned integer into an int, at the very least, no, huwag kayong maglagay ng int na ganyan lang. Tapos sasabihin mo, Basti, easy lang pala tong C. We should just do it like this para mag-convert. This is the wrong way to do it. The correct way is to put an assert here and make sure that yo is less than or equal to int max. That's the correct way to do it. Kasi kung sakaling sumagad yung yo mo beyond the int max, we should crash the program. Kasi unexpected yun, right? We should crash the program. And then it's only after we check na within int max siya, dun lang siya magiging valid C code. In fact, I think this will compile, I think. Ay, joke lang pala. Kasi unused naman siya. Ay, joke. Implicit conversion. Anong implicit conversion? What do you mean? I did a... Whatever. Okay, so I think masyadong strict yata yung warnings ko dito, or I just don't know. Ay, wait. Is the space significant? Oh my god. Oh my god, the space is significant. The space is significant. Oh my god. Today I learned. Oh my god. I didn't know na... Oh my god, you can't put a space after it. Oh my god, that would have bitten me somewhere. The space is significant. That's so stupid. Oh my god. Okay, well, so that's my point, ano. You turn on the warnings because you're going to learn something new every time. Ito nga, kahit ako niya nag-host nung study session natin, may natunan pa ako eh. So, always make sure to turn on your warnings. And if you want to make your life particularly difficult, make sure to compile with w-error para hindi siya mag-compile at all kapag may isang warning. Okay? So, let's just run yung singly and tcharan! That's it. So, yung initial nating print is to print the entire list. So, we have 0, 1, 2. Tapos, yung detect cycle should return null kasi walang cycle yung 0, 1, 2. Same din dito kay 3, 4, 5, no? If you push front, 5, 4, 3, list print, detect cycle should also be null. And then ito, if you try to concat them, dapat si A becomes 0, 1, 2, 3, 4, 5. Pero si B itself, kinonsume na natin siya, kaya star na lang siya. Right? And then if you try to list reverse it, magiging 5, 4, 3, 2, 1, 0 siya. And then if you want to print the list A itself, dapat, sorry, ito pala, nasa list cycle na pala tayo. If you wanted to detect the cycle itself, if you notice, we're going to say, hindi niya pinrint. Sorry, the data of where the cycle is. Okay, sorry. So yung cycle kasi dito is, meron kang 0, 1, 2, tapos si 2 points back to 0. So 0, 1, 2, 0, 1, 2, 0, 1, 2. Yun yung cycle. So it was able to detect correctly that the cycle was at 0. So ayan, cool stuff. And then probably another thing na hindi something na I hate seeing again sa mga resources like sa ni Geeks for Geeks, they keep forgetting to return 0 from main. So like, return 0, bro. Or like even better, return exit success. Exit success is a macro defined by the standard library na depending on your OS and what their definition of success is, magbabago siya kasi you can't assume that return 0 means success in all operating systems. So exit success just returns the correct exit code for success. Please do it like this. We're lucky na sa C standard explicitly na sinabi, if you have an int main tapos hindi ka nag-return ng integer at all, they're automatically going to insert it anyway. We're completely lucky that that's going to happen. Pero if you happen to do something stupid, like sinabi mong struct list yung ni-return nito, pero wala kang ni-return, tingnan mo ba, nag-raise agad ng warning yung editor ko. If you try to do something like this, ibig sabihin nito, yung function na to will never actually return. If you look at the machine code, si list create, dahil walang return yan, it's going to keep going downwards and downwards and downwards and downwards until it finds the first return. So yung mangyayari doon, itong si node create, ito yung first return. So yung return address nung function na yon will be the return address of the one that you wrote here. So, anyway, it's just bad. You know, yung point ko lang sa mga hindi pa nag-CS21, it's bad if you don't return from your function. It's just undefined behavior. Yun yung formal terminology for that. So don't be bad people. Make sure to return your non-void functions. And with that, no, that's the end of the singly linked list. I think in doubly linked list, papasadahan na lang natin kasi most of it is just the same banana. So yeah, do we have any questions before we move forward?
Nope.
Salamat, Ellis. Hi, Michael. Hello. Okay. We can now quickly look at... Saan nga ba to? We can now quickly look at the doubly linked list. So same attack as earlier, no? We'll be looking at the functions one by one. So, there we go. Si struct node, like earlier, meron tayong int data, meron tayong previous and next. Wait, before I continue nga pala. Talagang wala nang question, no? Like, we're goods. Last call. Okay, we're good. So, etong si doubly linked list, yung bawat node, hindi lang siya may next pointer to sa previous and the next. Kasi that's where the name comes from. That's why it's a doubly linked list. It has a previous and the next, no? And then, when you want to initialize a single node, essentially you give it the node pointer itself, self.data equals data, then self.prev equals to self.next, which is equal to null. So we just set everything to null. And then if you want to create the node, we just malloc assert that it's not equal to null. And then we initialize the node, return self. Okay, nothing new here. It's pretty much the same thing as we had earlier sa singly linked list. Pero yung magbabago dito, now instead of dun sa free function natin, hindi na siya isang free function lang. We have a function for freeing the chain forward, right? So if you follow self.next, and then, wait, kulang pala to ng self.next, if you free the chain, kulang to ng hindi, joke, sorry, hindi pala yung kulang. Never mind. So there's like a free chain forward, and there's also a free chain backward. Na instead of traversing forward, you go backward. So like .prev, right? So this is like the same implementation, pero you just traverse in a different direction. So I don't think I'll have to spend too much time there. Same din sa printing. Printing has a forward version and a backward version. So it's the same thing, I think. You don't have to delve into that. Okay? So speedrun ko lang yun. I hope hindi naman kayo masyadong nagulat dun sa implementation. You just go forward and you go backward. Yung magkakaproblema tayo dito sa append wala na akong nilagay na swap chain operation kasi it's a little bit more involved kapag meron ka ng doubly linked list. Kasi, okay, wait lang, let me try to illustrate that, no? Kung meron tayong doubly linked list, we have nodes that go forward and backward. So if you try to do the swap chain algorithm from earlier, na meron kang self, right? Meron kang self, meron kang other, tapos si other, possibly meron siyang si other, possibly siya meron siyang forward and back pointers to some other guys, forward and back pointer to some other guys, and so on and so forth. And same din kay self, possible din siyang may forward and backward, right? So, medyo hindi na trivial yung pag-swap chain. Kasi yung mangyayari niyan, if I want to connect itong si self to other, I kind of have to make a decision on what to do with the remaining nodes here and the remaining nodes here. What do I do with those two guys? Dun sa implementation ko, I just free them. Like, feel free to do whatever you want with the dangling chains. Pero in this implementation, I just freed them. So, what that would look like is, kukunin ko muna, like I will isolate the entire chain here, yung after the self node, and then i-isolate ko din yung the one before the other node. And then, I'm going to break the chain na going backwards to here, right? I'm going to break that. And then itong si forward chain, point ko na siya dito sa, bakit? I meant to use green. Tapos itong forward link, ilalagay ko na siya dito. And then in a similar fashion, i-break ko rin yung back reference to the other, like that. And then itong si blue, i-redirect ko na siya dito. Right? And then after this point, i-free ko na itong dalawang to. Free, and then free. Okay? Clear naman? Clear naman yung visualization nun. Actually, I can show you the code itself. Ano? Ito lang siya. Kung if some next node exists, just free it. If some previous node of the other exists, free it. And then overwrite may self.next, overwrite may other.prev. And that's how you append it, right? Ganun lang siya. Okay, any questions about yung append? Oh, I should probably tell you guys to saan ba yung emote button dito? I suggested activity. Rocket emoji, if we're all goods. I don't know where the emojis are. Ayun, dito pala. I'll do a rocket emoji. Tchanan! Wow! Okay. All seems good. Let's go. Let us continue. So, yan yung append. Hindi ko na siya... syempre, depende sa problem yan. If you want to keep track of the dangling nodes, feel free to return it from the function. Pero, for me, I just feed it. Like, there's no need to keep it around. So, anyway. Syempre, in the special case na walang laman yung next node, wala siyang gagawin, right? Kasi nag-if condition tayo dito, eh. So, like, if it is null, it don't do anything. There's nothing to do, right? So, okay, next one that we have to implement, prepend. How do you prepend something? Ito si append, right? Itong si node append is kung meron kang self, tapos gusto mong ikabit yung other after it. Pero ito yung baliktad. What if you want to put yung meron kang self, and then you want to prepend yung other before it? So it's like the same process, pero nag-iba lang yung mga pointers mo. Ngayon, self.prev is now going backwards, and si other.next is going forward. And then you still swap the pointers as earlier. So if you notice, like literally, mirror image lang siya nung append. Literally, yung prev naging next, yung next naging prev, yung backward naging forward, yung forward naging backward, di ba? Yung ganun. So, di ko na i-discuss to. I-visualize nyo na lang what I meant by prepending in backward order. Di ba? Yung ganun. Let me just quickly check here kung may... Okay, all goods. Okay, so now we can now talk about the linked list itself, no? The linked list, to implement that, you just need a head and a tail. Like, pretty much that's your classic doubly linked list. Ito yung parang sinasabi ni Judd kanina na what if you wanted to store the tail? Yeah, this is like where it gets tricky kasi now we have to do some bookkeeping to make sure that everything's intact. So let's start with initialization. You want to initialize it, self.head, self the tail equals null, right? And if you want to create it, we stack initialize it again. Hindi na natin kailangan imalok because, as I mentioned earlier, 16 bytes is not expensive. You can just put that on the stack and you're good to go. So, yun yung ginawa ko. Nag-allocate ako sa stack and then list in it and then just return it, right? No reason to malloc. Okay. And then, since we have the creation functions, naturally we also have the free functions. So ito yung free forward. So the free forward is if the head does exist, and then we do a free chain forward starting from the head. Pero if it doesn't exist, edi reset mo lang yung buong list back to 0. Right? Yung ganun lang. And then same din sa free chain backward. So si free chain backward, if the tail does exist, edi free the chain starting from the tail and go backwards, right? And then make sure to reset the list afterwards. So yeah, next up, printing forward. This should not be surprising to a lot of you guys. It is like the same logic as earlier dun sa singly linked list. Pero translate ko lang siya sa forward and then printing backward like this, right? And then this is where most of the utility of a doubly linked list comes from, is when you want to use it as a queue. So kanari sa queue, we have two operations, si push back and si push front. Ay, tama ba? Push back. Push front, pop front. Pero dito, for the sake of brevity, in-implement ko lang dito yung push back and push front. Parang I leave it as an exercise to you guys to do yung push. Pop back and pop front. Yeah. So, push back, if kung wala tayong tail, edi ibig sabihin nun, tayo yung unang-unang node na ilalagay dun sa doubly linked list. So we just assign self.head and self.tail to that same node. And then, kung sakaling not equal to null, edi we append the other to the tail and then we reassign tail to be the other para nag-move forward yung tail pointer natin. And then kung sakaling first time initialization to nung list, let's just make sure to set the head to be other. Pero if there's already an existing head, don't touch it, right? Okay? Is this clear? Or do I have to slow down? Ayaw nga pala, palis na si Alice. Sige. Do we have any questions? Just asking. Rocket emoji talaga. Okay. Sige. Alright, sige. I'll assume na we can move forward na. If you wanted to do pushback data, that's just a helper function that wraps some integer, right? Tapos node create, so I don't have to do that myself. There's nothing too special here. Si push front, this is like yung parang inverse ng pushback, right? So parang instead of pushing to the tail, we now push to the head. Tapos we move the pointers accordingly. Hindi ko na yata kailangan masyadong i-discuss yun kasi it's like the same logic as earlier. Pero instead of node append, node prepend yung gagamitin natin. Tapos si self.head, tapos si other, right? Same banana. It's all the... I don't think there's anything new about that. Tapos ito, push front data, another helper for pushing the data. So yeah, let's take a look at what the main function looks like. Medyo mas maikli siya than the doubly linked list kasi I feel like you guys get the point already. I don't have to do another iteration of how to do a linked list kasi we've done the singly linked case na. So ayan, I think parang cool na interface natin. Meron tayong push back, push front. So kumbaga meron tayong 1, 2, and then we push front kaya magiging 0, 1, 2. So we print forward, we print backward, and then we free forward. Yun yung we could also do free backward, pero I don't know, like feel ko lang siyang gawing free forward. Same banana counter. Okay. So, yeah, let's take a look at what's this? Salamat, Judd. Salamat. Let's compile with yan. Doubly, and then let's run it. There we go. 012210, right? Nothing too crazy. Hindi ko na in-implement yung mga split get node, get last node, whatever. Because I think you guys can just like adapt that from the singly linked list. Mag-ingat na lang kayo dun sa tail and sa head pointers kasi you have to make sure na ma-maintain mo sila correctly. Otherwise, you guys are gonna deal with a lot of seg faults. So, watch out for that, no? So yeah, I think we've reached the end, no, of yung singly linked list and yung doubly linked list. And siguro yung parting words ko before we close the session, no? Kasi all this time, yung grand twist that I wanted to show you guys. Well, kasi alam ko maraming nagtatanong kasi dun sa Acad Inquiries kung meron ba kayong C resources that you would like to that you would like to share. And one of the things that I jokingly shared was yung the Rust book, which is like yung official tutorial for the Rust programming language. Pero it turns out yung entire tutorial session na to has been like a Rust shill all along. Parang you guys fell right into my trap. Kasi it turns out yung interface na ganito, like yung interface na ng doubly linked list is something straight out of the Rust standard library. So kanare, if you want to know how to implement a proper linked list, you can actually look here on how Rust does it, and you can see yung mga different methods that they have for a doubly linked list, right? So you can see where I got my inspiration from. Meron tayong pushback, meron tayong push front, meron tayong pop front, meron tayong pop back. So ngayon, kung papagawa kayo ng linked list ni Sir K, I highly recommend going through yung standard library ni linked list dito sa Rust and just look at the operations that you can do to a linked list here and re-implement it in C. So that pagdating mo sa Hope exam, meron ka ng standard library of functions that you can implement yung solutions mo. Right? So parang, why should you care about self.next equals whatever if you can just wrap that up into a helper function na kunwari dot front if you want to get the first element, dot back if you want to get the last element, and so on and so forth. Diba? Like, I hope you see my point here na the entire point of CS32 is for you to not think about the individual instructions. It's for you to think in terms of operations. Think in terms of data structures. Parang hindi na to CS11 or CS12 na iniisip mo na siya at the level of I++ or whatever. We have to think higher than that. We have to think na meron tayong linked list. What can I do with the linked list? I can pop from it. I can push from it. I can look at the first element. I can jump to the last element. That's going to be O of n time kasi singly linked list yan. But if it's a doubly linked list, I can do that in O of 1 time. Diba yung that kind of that way of thinking about implementing algorithms, hindi na siya step by step. It's structures and structures and structures and structures, right? So if you're looking to up your linked list game, I highly recommend re-implementing all of the methods here dun sa standard library ng Rust and do it in C. Like, you're gonna have a fun time. So kunwari, append. How do I do an append? Dapat meron kang self and meron kang other. How do I implement back? Dapat meron kang self and you should return null or some pointer to a node, right? Contains. How do you implement yung contains? That's pretty well. Medyo spoiler. You can actually look at the source code and it's literally just get an iterator and check if any of them is equal to x. Diba? Parang medyo spoiler yun, pero you can look at the source code and see exactly how they do it. Pero that would be my parting words before we wrap it up. CS32 is the story of data structures and operations, not I++ or I equals 0 or if this is equal to null. We have to stop thinking at that level and start building abstractions on top of those so that we can solve problems in terms of data structures and algorithms. Parang gone are the days na parang CS11 or CS12 style of solving, no? Na iniisip mo lang yung at a per variable basis. So yeah, siguro one interesting thing na in-implement din dito sa Rust is like the cursor. So parang given a linked list, it's gonna give you a cursor into that linked list so you can like go forward and backward and forward and backward. It's really cute, pero kayo bahala on how you want to re-implement that. So yeah, I think that's like the end of the entire thing I wanted to talk about. Do you guys have any other questions, no? Before we wrap things up? Listening to this while I sleep. Okay, let me quickly stop streaming. Let me know kapag other questions kayo, my dudes?
I have a question.
What's up?
Can you repeat everything from the start?
Oh my god. Which one? Ano yung start
I'm
na
just
yan?
joking. I'm just joking.
Ay, okay.
Bro,
Okay,
that was
okay.
a joke.
Okay, nakala ko talaga.
This guy's too nice.
Ano eh.
This guy's too nice.
So, ayan. Definitely, if you wanna practice your data structures, just copy the standard libraries of other languages. You can even do it in C++. C++ also has a good resource for that. How do you generally solve a problem? Like if you were to encounter a new one, or say you are trying to create a function for a project that you're working on. Yeah, okay. So for that, as I mentioned earlier, hindi ko na siya iniisip in terms of the explicit steps that I need. Yung iniisip ko ngayon is, what are the data structures that I need to make my job easier? And then let's just import that. Yung ganun. So sa Python yan, if I need like a priority queue, kanari ini-implement ko yung Dijkstra's algorithm, sabihin ko lang, okay, I need a priority queue. Import a priority queue, di ba? Yung ganun. So hindi ko na iniisip yung the internal details of a priority queue. Yung point ko lang is, if I want to do Dijkstra's algorithm, just give me a priority queue, and I'm going to form my algorithm around that, right? Parang you break away from the low level thinking and start thinking in terms of the operations that you can do to manipulate yung mga data structures na yan. Kasi that's pretty much this entire story of CS32. Parang how do you deal with some data, and what are the operations you can do with that data. So to solve, I guess to answer more directly, no, how do you generally solve a problem? Parang first tinatanong ko is, will a linear search like solve the problem? You know, parang like, will a naive solution solve the problem? So if I had a naive solution, ano yung mga data structures na kailangan ko for that? Kunwari, iterate over all the elements in this whatever. Sabi ko, oh shit, that's an array. Kasi sinabi niya, iterate all over the elements. So first instinct, array. And then suddenly sinabi niya na, oh, by the way, make sure that everything is sorted at all times. Oh shoot, sabi ko, okay, so since everything is sorted, I think I'm gonna need a min heap or something, right? Or a max heap. So hindi niya pa yata na encounter yung max heap and min heap, na. So medyo spoiler pala yun for the next topic. Pero whatever. So kanari may mga problems din na medyo dead giveaway yung algorithms na kailangan mong i-implement. So kanari, given a sorted list of whatever, whenever you hear the word sorted, automatic yan, binary search, right? Whenever you hear that word, your brain should immediately jump. Okay, this guy wants me to do a binary search. So parang that kind of level of thinking, no, na hindi mo na you think in terms of concrete things that you have to import from somewhere, and then you just invoke it onto your main algorithm. So I hope that helped you out, yung tip na yun, kasi that's a very high level way of answering the question. I'm not sure if it's as actionable as you hoped it to be. Sorted equals binary search. Probably not in all cases, pero parang medyo dead giveaway, kasi parang given a sorted list, okay, sige, let me just log in that, diba? And then you're good to go. Sige, so what else? Do we have other questions?
Ang galing mo naman magturo, Basti. Wala silang tanong. Nagets nila lahat. Grabe guys,
Oh
tanong
my
lang
God.
kayo. Parang ako lang nagtanong. Nagmumukha akong bobo. Sige na, please. Do
Pero
it for
hindi,
me.
maganda ngayon,
Do it for
Hindi,
me.
yung parating nagtatanong, siya yung nag-improve
Wow.
ng sobra, di ba? Yun eh. That's how you do it.
Wow. Thank you.
Mamanos multitasking. Hindi, I think gets mo naman doon kasi yung whatever I was already explaining. So you're chill, my man. You are chill. He's vibing. Yeah, sige. I should probably, para fair naman dun sa sa mga C++ fans, I should probably show you guys yung list implementation nila. I think they have like the same names, no, for the operations. Okay, let me just quickly look at this. Medyo same. Not, yeah, it's actually the same. It's actually the same. So, parang look no further, no, than the standard library of other programming languages to see how to implement something correctly. So, ayan, meron tayong clear, meron tayong insert range, emplace, erase, pushback. Emplace back is a C++ specific thing na necessary, so let's ignore that for now. Tapos meron tayong pop back, push front, pop front, prepend range, resize, swap. Swap.
May swap?
C++ may swap.
Oh,
Would you look at that?
kaya pala may plus plus.
Kaya what?
Dagdag yung function.
Okay. Tapos ayun na, meron din silang reverse, meron din silang unique, removes the consecutive duplicate elements, you know. So if you need like some inspiration, no, on what can you do with a linked list, just look at the standard library and then pag binatuhan ka na ng problem ni Sir Kevin, you may recognize mo kagad, yan yung sinasabi ni Basti, swap chain lang yan. Or I just have to push front, or I just have to reverse the list, I just have to insert this into index whatever, right? It's like you don't think about the low level details now. You think of them in terms of the operations that you want to do on the data to solve the problem, diba? So I think that's like a more effective way of reading the code. Okay. So I think that's the thing I wanted to show. Any last questions, my dudes? Actually, sa totoo lang, I'm just gonna be waiting here for the entire time. Mag-chill lang kami. Extensions! Right! Oo nga.
Why
Ikaw,
do
nag-in-open
you
ka ba
code in
recently,
Vim
Julia?
and not in VS Code?
Ako?
Oh.
Because if I do it in VS Code, VS Code has this vibe na magic yung editor. So, like, when you do
Kaya siya
F5,
maganda,
you don't
magic
really know
siya.
what's happening, right?
Oh.
I mean, recently, tinuro ko sa'yo yung tasks.json, di ba, Jod?
Oo.
And parang it's like hidden behind you. Pero when I did it through NeoVim and through the terminal, there's like no magic behind that. It's exactly what's gonna be happening if you had done it through VS Code. So parang I just wanted to illustrate that there's no magic there. It's just putting a text file into a compiler na may executable, di ba, yung ganun. So it's mostly for your sake, I guess, na ginawa ko siya na raw than relying on the magic tools of VS Code. Because at the end of the day, that's what they do, no? In-automate lang nila yun. Smooth Cursor, that's from yung Go NeoVim, yung ginagamit kong, ano tawag ito? Yung ginagamit kong editor, GUI for NeoVim. Meron silang Smooth Cursor na option. So it's not really a native Vim thing. For the extensions, I want to answer yung tanong muna ni Lucas. What is your favorite C error? Look at pinakita ko to kay Judd the other day. This is my favorite. My favorite error is not an error at all. Okay. So, if you've ever found yourself needing to convert a string into an integer, yung first instinct mo may probably be looking here sa A to I. Diba? Parang converting an ASCII to an integer. Pero the funny thing about A to I is that if nag-fail yung conversion, 0 will be returned. So yung error case is 0. Pero that kind of means there's no way for you to know kung successfully siyang nag-read ng 0 or kung nag-error siya ng 0. So yung favorite kong C error is the error returned by A to I because it's the dumbest interface ever. There's no way for you to know if 0 was successfully parsed or if it's a 0 na error code, right? So this is my favorite for sure. So syempre, please don't use A to I. Yung alternative niyan is to use stir to L or I. Stir to D, I think. Yeah, stir to D.
Or even
D is double pala. Sorry. So dapat
Stir to
stir
L,
to
diba?
L.
Stir to L.
Ayun.
For
There we
more
go, yeah.
more context, kasi I was watching the Harvard CS50 Premier course for learning linked lists, and they mentioned A to I. Tapos I was like, oh shit, Atoy, this is so cool. You can turn an entire array into strings in second. And then Basti was behind me. It was like, no, don't use Atoy. the the C documentation specifically says to avoid using Atoy. I'm like, Basti, this is Harvard. No.
Oh my god. That's so
Oh, I
true.
can- It's so unfortunate I didn't see that exchange.
It
Ako,
was so
gulat na
funny.
gulat ako. Ang
Sobrang
cool na
excited
to.
pa niya nun eh. Ni John. Oh my god, it's 8i.
You can make the entire array into strings in one line of code in C. That's crazy.
So ayun, Lucas, just to answer your question, definitely A to I. The error from A to I. Like, undisputed.
I like calling it Atoy. It's so fun.
Atoy. So just to answer yung tanong ni Julia, extensions. Very minimal yung extensions ko. Oh wait, what am I
You made
doing? I
this-
could like just share the entire screen. I could just share the entire screen. Kasi,
Oh shit.
I can just share the entire screen kasi I can show you na, let me close this. Yung plugins ko, essentially, it's just this. And it's a lot. Well, very minimal compared to a lot of other people. Color scheme, basically edge, status line, ito lang, very minimal. I don't even use icons kasi I don't really like to install nerd fonts. Tapos yung indentation for the blank lines, I use this one. And then other helpful functions for text editing, or tapos yung Vim Fugitive for using Git inside NeoVim. So kunwari ganyan, yung if I want to do something like this. I rarely use it pero whatever. Ayan, I'm not gonna like go through all of this kasi medyo marami-rami yung mga plugins. Though, I will refer you to my NeoVim RC repository dito sa GitHub. So if you want to figure out how to set things up my way, no? Naka-open source naman to. You just visit Bastidude, NeoVim RC. Tapos punta ka lang dun sa configs ko kanwari, and then plugins. Just like the same file that you saw from earlier. And cool. I don't like to even install nerd fonts. Oh my god. So yan, okay. I think ito na yung parang chill point na. So we're just asking whatever questions na. So thanks guys for attending, no. Siguro we should like ano ba yung next data structure na inaaral nyo? Kasi it would be cool if we could do this weekly, habang may oras pa ako.
Oh,
Wala, parang mamatay ako.
I'm not sure yung next. Kayo ba, guys? I think last time was...
Depende sa
Lovely
depende
eh.
sa topic ninyo. Kasi kung kanwari walang new data structure naman, edi you don't really have to, right? You don't really have to
I'll
do
end the
another one.
recording here muna. I think